Yo, welcome to the first command-based tutorial, and so far the only one. In this tutorial, all I'm gonna be going over is what's a command op mode, subsystem, and command, and how to make your very first drive command. So making the robot move with command-based programming. And so, welcome to the world of command-based. So, why would you use this over normal code? Organization. It looks all nice and neat. You can find things. They're all separated between your commands and subsystems. Everything is easily accessible. It's much easier than cramming everything into like one or two files. Simplicity. Once you get the hang of it, it's super simplistic. It's just make a subsystem, make a command, make another command. Eventually I'll go over command groups, make more of those for auto. It's really easy and straightforward. And third reason, it looks really nice. And it's just like people have like this newfound respect for you if you know command based. You feel me? So the outline of it, like what's like the basics. So your command op mode, it's like your Teleop or autonomous. It's where you put your subsystems and commands and register and schedule them. I'll go over registering and scheduling later. And so there's also the subsystems. It's like how the hardware is accessed and like where you define the basics of the commands. And then there's the commands. It's where all like the complex tasks are done, and they're like the kind of like the heart in my opinion. They're like without the commands it doesn't work. And so an important note is it needs to be scheduled. Now, what is scheduling? In the most basic terms, it's like running the command. Scheduling the command is like saying to run it. You say schedule this command and the robot says okay, and it just does it. Now there are a couple ways to schedule commands. You could straight up just say schedule, or you could bind it to a button. Those are the two main ways. There are a few outliers, but I'll talk about those in a bit. But the two main ways are either by saying schedule and then the command, or saying when X is pressed, do this. And remember, always schedule your commands, or they're literally just not going to work. That's it. And so, now, I will show you actually how to apply these concepts into your first driving program. So, here you are, Android Studio in team code. Firstly, what do you want to make? Probably your Teleop. So, for this tutorial, I'll just call it command Teleop. And so, once you've done that, what you can do is extends command op mode, and so that, and then and implement methods. And so then when you do that, it's like saying, okay, this is the command Teleop, like this is how you're gonna run all your commands within this initialize thing. And well, yeah, last thing, or first, you could do this in any order. Teleop, and then I like to set the name, so name equals op. Setting the name is good practice. If you don't set the name, it's fine. It'll set it to whatever your class name is, so command Teleop. And so this is all we can do for now. We can add motors maybe, but it's not like we can do anything with them without the subsystem and command. So, next, want to make the drive subsystem. So I'm going to make a new class, drive subsystem. And so to say to call it a subsystem, all you need to do is extend subsystem base. And so now it's like, okay, this is a subsystem. I know that now. All the actions performed will be based off of the subsystem base class. And any classes that extends. So, first, for this tutorial, I'll be using a mechanism drive. Purely because that's what my team uses. So, for that, all you have to do is do private, whatever your drivetrain is. For me, mechanism drive. And then drive. And then while I'm at it, might as well say private and then define the motors. So front left, front right, back left, back right. That was probably a bad order to do it, but that's fine. And remember to import everything. And now, let's make that constructor. So public drive subsystem. And then what we want this to take in are the motors. So motor, front L, motor, front, oh my god, front R, motor, back L, motor, back R. And so it's taking in the motors so it can use them within the commands and whatnot. And so lastly, all you have to do is FL equals front L. I spelled FL wrong somehow. That's fine. That's totally fine. FR equals front R. And then do this for each motor. So you can use them in other parts of the class essentially. And then BR equals back R. And look at that, you finished the constructor. No, you didn't. That was a lie. You didn't finish the constructor. I lied to you. Lastly, what you have to do is say drive equals new, whatever the drivetrain is. Mechanism drive in my case. And then just kind of shove those motors in there. So you can apply them to the drive. So it's like, okay, these are the motors which I'll be using for my drive. Front left, VLBR. Easy stuff. And so finally, got one more thing. We've got the thing that the command is gonna like reference. It's like the command is gonna go, okay, call this when the command is used. So public void, I'll call it drive. And then, so for a mechanism drive, you'll be taking in 3 values. For other drives, you may be taking in different values. For such as like for a tank drive, you'll be taking in left movement, right movement. For a mechanism, you'll be taking in strafe speed, forward speed, and turn speed. Simple stuff. And so all you have to do now is do, for this tutorial, I'm going to be using robot centric because it's easier, less work. And all it has to do is say, okay, use the strafe speed, forward speed, and turn speed. And boom. That's your subsystem for driving. That's all it is the entirety of it. I don't have to add to this unless I'm making some new drive commands. Like this is all it is. And so next, the command. The most important piece. I guess they're all equally important, but in my opinion, the most important piece. So drive command, make a new drive command class, or whatever you want to call it. And so we want to say, okay, this is a command, and it's the exact same thing as a subsystem. Extends command base. Boom, it's a command now. But wait, there's more. Let's define that subsystem. private drive subsystem, drive subsystem. And then we need to, for this, because we'll be getting doubles from the controllers as inputs, because we'll be using the joysticks in this example. So we'll also be creating double suppliers. So private double supplier, and then strafe forward and turn. So we've created double suppliers so we could get the strafe speed, forward speed, and turn speed from the controller within this command Teleop. And so there are only two more things left in this. The constructor. And so for the constructor, oops, not that, do not put that. All right, for the constructor, public drive command will take in the drive subsystem from the command op mode. And we'll also be taking in those double suppliers, which I mentioned earlier. Strafe, double supplier, forward, double supplier, turn. So all I have to do is then equal this dot drive subsystem equals drive subsystem. This dot strafe equals strafe. Oops. Don't forget your semicolons. Those are very important. And so once you have all of these values equaling the ones within the constructor, you have one more thing left in the constructor. Add requirements. This will be saying, okay, this uses this subsystem. And you know what subsystem this uses? The drive subsystem. Because we don't have any others, so that wouldn't make any sense if I were to put another one. Also, this is to drive. That would make any sense if I were to say lift. And so there's one more thing. We need to override the execute method within the command class. And so to do that, we just do @override and then public void execute. And so what this is saying is, while the command is scheduled, this will constantly be in effect. So drive subsystem dot drive. So that's the method within the drive subsystem right over here. And so then all you gotta do is do strafe dot get is double, forward dot get is double, and turn dot get is double. And there you go. You've made a command, a subsystem, and you've made the little outline for your Teleop. There's one final step. One little tip of it. You gotta put everything in the op mode. So, what are we calling in these constructors? We need the motors. We need the subsystems. Not the subsystems, the subsystem. And we'll need the controller. So, up here, I'll go private motor FL, FL, FBL, FRBR, get import. And then, so you have the motors, and now you need the subsystem. So private drive subsystem, and might as well call the command as well, because that will make it look nicer than saying new command. Drive command. Okay, and then one more thing. So it's getting these double suppliers. Well, what's it getting them from? The controller. So we'll also need to import gamepad X. Gamepad X. And then, I don't know, m underscore driver up. Now, these don't equal anything. All we did was say, okay, these are objects we have, that's it. Now we need to make them equal something. This is where people are experienced. All it is just this tedious saying, okay, front left equals new motor, hardware map, and then whatever the name is in the config of the motor. So FL. BL is just the same old, just doing this for like a whole minute. But still, we're almost done. We're so close. Can you feel it? I can feel it. Because look at this. Motors are almost finished. Oh. Oops. I got cocky there. Boom. The motors have been... Now we've said, okay, these motors. These motors, yep. And so... Now... Let's say we need to define that gamepad. So, and this equals new gamepad X. And then gamepad 1. And if you're using a secondary controller, it would be gamepad 2. And then boom. There's pretty much only 2 things left to add here. Maybe 3, 4. And by things I mean lines. That's how much we have left. So all I have to do is drive subsystem equals new drive subsystem, and then all we got to do is take in the motors. So FL, FR, BL, BR. FL, FR, BL, BR. Boom! We've taken in the motors. Brilliant. And then let's get that command set up. Drive command equals new drive command. And then so if you remember, we take in the subsystem, and there are 3 other parameters. So what we can do here is m underscore driver op : get. And so for the strafe speed, we want it to go left and right. So the left X, so the X position of the left stick. M underscore driver op : get left Y, so forwards and backwards. And then M underscore driver op : get right X, turning. You don't have to make it these controls. These are just good controls for it. And then literally just like 2 more lines. You have to, so what we're going to be doing here is setting a default command. And so it's like it'll automatically schedule the command. So it'll say, okay, always be running this thing as long as the subsystem's going. And so we'll say drive subsystem dot set default command drive command. However, there's something you want to do before this. Normally, you do not have to register a subsystem unless you've unregistered it. However, if you're setting a default command, it's good practice to register the subsystem before you set the default command. And so, here it is. This is your entire Teleop if you want to make the robot drive. This is all it is. This is the subsystem. This is the command. With all of this, your robot drives. Now, this is all I'll be showing for now. In the next tutorial, I'll show how to make like the basic subsystem, like for instance, making a shooter. And in later tutorials, I'll go over command groups as well as making this work in autonomous. But that's it for now. As of FTC lib pre 1.2.0, this is it. Thank you.